probably 100 ways you could get there as far as clocking this in the right position so that we get 10 degrees off of our hole that we just made. I figured it was easier to go this way rather than make that mark and then drill the hole. So what I've got here is a 187 gauge pen, and I'm gonna go with my Starrett number 995. I actually bought this at the Summer Bash 2018, I think, from somebody that was selling a whole bunch of Starrett there. I can't remember his name. But anyway, haven't used this a whole lot, but for stuff like this, it's perfect. And then I've got my Toolmaker shop-made 10-degree angle gauge. So what I'm gonna do is keep it in my V-block here, and then bring up my planer shaper gauge until I've got enough room to get my angle block underneath that pin. And then there we go. So that should work just fine. Like I said, there's probably 30 ways to do this, and maybe this is the dumbest, but it's what I thought of in the last minute and a half, and it worked, I think. So as far as our cutter goes, we are gonna use a little baby 1/8 inch chamfer tool. This is an AccuPro 1/8 inch by 1.5 inch overall length, 90-degree chamfer tool. It's double-ended, so when this inevitably breaks, I've got one other end I can use. So let's change out the, put that collet in there, and then we'll go down. The length of it doesn't really matter. The depth of it doesn't really matter. It's just gotta be visible, basically. So, you know, make it about 1/4 inch long and not very deep, but it'll be in the right position, and that's the important part. I think we're ready to go. Got the cutter moved down a little bit, and I think what we'll do is just move this over to the full diameter and just raise the table up until we start making a little tiny chip. Okay. Yep. Yeah, we'll go a little tiny bit further as far as the length of the mark. Yeah, looks good. Let's go up another few thou. It was a little baby cutter at 2,000 RPM, which obviously on a CNC machine, that would be basically crank it up until you run out of RPMs, but I'm totally fine with that. All right, we're on to the tough part. This is the one I've been thinking the most about, just because don't want to have to make a new blank, although that's not that big a deal. So I think what we're going to start with, we've got the machine already set up for that high-speed little chamfer mill. So I think what we'll do first is make our little mark here. So that times this whole thing with the holder for this turret, and that determines your grind angle on the point of your drill. So using my little Fowler digital edge finder, we'll find our center of the turret blank. It's held in a little square collet body. I'm thinking we're probably not going to take it out of that until we're completely done. I don't think I'm going to run into any clearance issues anywhere. I don't think, you know what, I guess I am. So maybe what we'll do is we'll loosen this up and extend it out a little bit so that when we drill this hole and run the tap through there, we've got a place for the chips to go and the point of the drill to end in free air. So I think that's what I'll do first, loosen this up and extend it out just a little bit, and then we'll keep the blank in the collet for the rest of this, the rest of the project here. Going to use our half function here, half of y, and that tells us where we need to be on the y-axis to get exactly where we need to be, right in the middle. Okay, I think we're good to go. Got our tool changed out. Back to our little baby chamfer mill. Have to crank the RPMs back up. And we're still in the center of our part. We'll try and do this without banging into the tripod, but we'll get lower with the quill. Oh, look at that. We're already touching. Okay, and let's find our maximal travel here. We'll set that to 0 on the PRO. And again, it's not like it really matters, it's just a mark so you can see what you're doing. So let's do 5/1000ths at a time. Obviously the aluminum is going to be a lot more gentle than the steel was in the last part. Just keeping an eye on the DRO so I don't crash. Always a little uncomfortable taking your eyes off the part. You don't want to break that carbide tool. All right, we've got our part in the vise here. It is nice and true with the spindle. And then I ran the coaxial indicator in. So we're well under 1 thou. Each line is a 1/2 thou there. I've been debating what order of operations to go through on this, and I guess I don't really have a great answer, but it seems to make the most sense to me to go ahead and do this hole first and tap it down here. Before we do the slitting saw, I don't think it would matter if we did this hole first or this one first, but either way, you know, doing both of them before the slitting saw makes sense to me, just because without that material in there, this would compress a little bit while you're drilling and might cause some inaccuracies. So there's probably a best way to do this, and I don't know that I chose it, but you know, basically it's what we're going with because it's what I've got. So first thing we're going to do is drill our tap size, which is a letter F for a 5/16 18 thread in the bottom of that. And then we'll drill halfway down to with a larger drill for clearance. And then we'll send our tap down in there and cut those threads in place. So that is basically the clamp bolt. So when the drill carriage is in here, you snug it down with this guy so that there's no slop in how you're moving the drill up and down against the grinding stone. So let's change out our tool here. We've already got our center determined, so change out our indicator rather, and we'll put in a drill chuck to start making a hole. And just to double check our work, we're still in the center on the Y, or I'm sorry, on the X. And let me go ahead and lock the table in here. There's definitely some slop in this thing, so I've got to play with it a bit with the lock halfway down to make sure it doesn't move around too much. But anyway, I moved the Y out a 1/2 inch, or I'm sorry, 1 inch. So that should put us right on the very tippy edge of this, and it does. So that is great. Means our indicating was successful. So we'll put in our spotting drill. So our y-axis, we're right on the very edge of the outside of the part. It's 1 inch from the center. So we are going to go in 538 thou, or rather we're going to go in until it reads 538. Okay, 538, and that should put us 462 thou in from the edge. So we'll make a little dimple with the drill. So we'll, in position here, 538 from the center. So we'll just make a little bump with the drill point. And with our calipers, we will see if that looks right. From the edge of the part, there we go. Yep, 461.5 is what my calipers are set at, and it's catching on that little mark. So we should be good to go. We are in gear. Let's go ahead and make our little spot. Should be good to go. Letter F drill in here. We're going to drill through everything. About like that. Come out the bottom. We should still be perfectly in line with our little scribe mark that we made first. And hopefully we got everything calculated correctly. Just kind of peck drilling here to try and keep it accurate. Obviously our jobber length cobalt drill is not going to be super straight. If I had a carbide drill, I'd certainly be using it. There we go. Went ahead and switched out to a stub length or a screw machine length drill, and then touched off a parallel, raised the table, the difference, so the height or the thickness of the parallel. So now we are at where the point is at the very top of this surface. And we're gonna drill down 520 thou. So that'll give us enough to hopefully make the hole completely round instead of just having an angle in there. But what that gives us is still inside the, still within the slot. So there won't be any impact below into the threaded hole. So that's the plan. Let's see how it goes. We're going to feed the table up rather than bring the quill down. Always very uncomfortable power tapping, but not going to get better at it if I don't keep trying. There we go. Didn't hit the collet even. So now we're sitting in this position here. The first hole we made here to the front towards the operator of the machine here. So we just need to find this edge and this edge, divide by 2. That'll put us right in the center. I'll double check that to make sure it is in fact centered. It sure as heck looks like it. But we'll do that, and then it'll be time to make a hole. Got our reamer going. And this isn't a great setup. I don't have a floating spindle here or anything. So we'll do our best, but this is not ideal conditions by any means. So we can't do the slitting saw operation just yet. I don't know how I did this, but I must have just had it in my mind that that slot was an 1/8 inch, but it's absolutely not an 1/8 inch, and I guess I never measured it. So what we can do instead is go ahead and get our small 1032 hole here figured out. And instead of getting the coaxial indicator back in here, or measuring with a test indicator, I went and grabbed a gauge pen. This is 499, which is the same as the original part. 499 would fit, but 500 wouldn't. So what we're going to do instead is use our edge finder again, because the hole that we need to drill is exactly in the center of this hole. It's a number 21 drill bit for 1032. Back to our old friend power tapping. Even more nerve-wracking with a little tap, but should have confidence, right? Still got some clearance in there. All right, there we go. What we're putting in here is a little, looks like just a regular set screw, but it's actually got a, ooh, well, and I just lost it down a hole. Here we go. It's actually like a piston. So there's a spring inside the screw. And basically what we're going to do is have a nut on the top side here, and you set it in position where that ball is in the groove of our drill carriage. So in that little slot is where we're going to have this little ball bearing sit. So there we go. That way you've got kind of a definite spot where it should be. So this awesome tray is made by my friend Connor Smith. He's got a great Instagram that he shows a lot of stuff doing these vacuum formed parts and making cool things for his canoes, or his kayaks rather, that he and his dad like to ride around on, pilot? I don't know how you say that. Go kayaking? Anyway, so he makes these in his shop here in Arizona. Go check him out. I'll put a link in the description to his website, CW Smith Co., and I'll include his Instagram as well, so you can contact him through his website or his Instagram. Really good guy, young kid making some really cool products. So I didn't set this up. This is like, this is how I use it. He gave me a couple of them a few months ago, and I've put them to use exactly like this. So I've got my, when I'm organized, sometimes it gets a little bit less pretty than this, but put my spot drill and then my tap size or whatever I'm going with, and then my chamfer tool and then the tap. So that's exactly how I had it for that last hole we just drilled, because it keeps everything in order, and I can pick this up and take it to the welding table or onto the mill table or whatever, and it's no problem. So anyway, very handy, very, very useful stuff. He's got a couple of designs. And then this is something that he has just released to sell to people, and he calls it the TIG Torpedo. And the reason it's called that, this is aluminum body and aluminum fins. It's just got this little plastic cap with a steel reinforcement in there. And this has got a bunch of tungsten electrodes for TIG welding. So instead of my usual mess where I have a stack of my tungstens just sitting on top of the welder, or it'll be on the edge of my welding cart and they roll off and can't find them whenever I need them, this has been a godsend. So he's making those and selling them for pretty reasonable money. So go check him out. TIG Torpedo and his organization trays. He also sells these, the purpose for putting them in your toolbox, and I've got one in my toolbox for all my small measuring tools. So thanks a lot, Connor, and you guys go check him out. We finally got our slitting saw blade in. This is a 4" by 3/32 thick. Got it in the arbor here and was just getting it in position to cut right down the center of this part. And it always pays to double check your work. I thought I had calculated everything correctly coming off the top and then measuring down with the quill DRO, but I wanted to be sure. I didn't want to cut not in the center. So I got some gauge blocks here. This is a 102 block and this is a 106/10. So total is 202 6/10. And it doesn't have to be that accurate, but I've got gauge blocks that'll get me that close, so might as well. And when I first put it on here, there was still a drop down on the top. And then on the bottom, there was a lip on the gauge pin. So I realized then that I had made an error just by sticking the gauge pin in there and grabbing a couple of gauge blocks. So that would have really irritated me if I'd cut this off by, 10 or 12 thou, whatever my error was. So just a little tip there to always double check, and gauge blocks and gauge pins are super handy. So let's get set up. I'm going to grab my paper so I remember exactly how deep I need to go from this side, and then we'll touch off with the blade here. And I guess we're just going to go full depth. I don't see any reason. It's aluminum, and even though we're not going to use any spray mist or anything, I don't think it's going to be a big deal. I'll put some Tap Magic on there and we'll be all right. So yeah, let's get the mill powered on and touched off, and we'll see how deep we need to cut. That was almost really bad. Okay, recovered from our little incident there. Went ahead and put the cutter arbor in the collet instead, and then we've got our part out, indicated it in both directions, and then it's clamped in a V-block with a little shim piece of aluminum to keep from messing it up, hopefully. Okay, that should do pretty well for now. We'll do a second cut to get down into the back here. So there is a secondary cut behind the hole. I think that's one of our problems. Is it was earlier was it was trying to pinch. So we'll do a new setup for this because I've got to change the spacer underneath the cutter here. And then we will cut that second one, and then we'll go to the back and cut that. We are all done with our turret part. I went ahead and just did the rest of the sawing off camera. That's not that interesting to watch. So did that and then took it over to the buffer and 10 minutes on the buffing wheel just for fun. Make it look all nice and shiny. Let's see. There's me. As you can see, the license plates on the wall in that reflection. So came out pretty good. There's really nothing wrong with it. All the dimensions are on, and we just had one little goof where I dropped it out of the saw, so that didn't quite clean up, but otherwise we're in, looks pretty good. Came out really nice. So the video has gotten way too long, so I'm gonna cut it off at this point, and then we'll do the assembly on a separate video. I'll try and get them edited at the same time, so you can just continue on watching and see how it all goes together, but the video as is way long enough. So anyway, that's our last part made and finished up. So let me swivel you over here to the rest of the parts. Here we've got 2 complete Lisle drill grinders. They both need a little bit of cleaning up. So we'll get to that at some point. I'm not super worried about it. This one is going to a buddy of mine if he still wants it. If he doesn't want it, then I will strip it down and get it painted and polished, and then sell it for making a couple of bucks on it. And then this one will be mine. I've got all the original parts staying with the original drill grinder, except, well, so this diamond bit holder actually came with this machine, but rather than giving my shop-made tool to somebody else, I'll let them have the factory tool. They're basically no different, but anyway, it just seemed like the better way to go. So yeah, thanks for checking out the channel and watching the making of all these little parts and pieces, and we will get to assembly here in just a bit. Thanks for watching.